Um, Hello, I'm Meenakshi, and today we're doing a review session on the topic projectile motions in IB physics. Um, I'm hosting the meeting, and attendees, you can start introducing yourself.
Hi everyone, my name is Paarth and I'm excited to be with you today.
Hi, I'm Shriya, and I'll be joining in for the physics review session.
Okay, so we can get started with some practice problems. So I'll just start reading this problem. So it says the Essex County Sheriff is trying to determine the speed of a car that slid off a small bridge on a snowy New England night and landed in a snowpile 4 meters below the level of the road. Tire tracks in the snow show that the car landed 12 meters measured horizontally from the bridge. How fast was the car going when it left the road? So I'm just going to list out the known elements. So I think our y value would be like 4 meters. And then it's 12 meters horizontally, so like that. And then we're asked to find the time. So I guess I'll try to draw it. So
Yeah, and then I'll write the UX components on the side.
okay.
So we're actually trying to find UX, right?
Is that how fast?
How fast
Right,
should be the
sorry.
speed, yeah. So here, could you clear the Y equals so we can separate between UX and UI?
Yeah, so I could erase the y and x.
Yeah, so we can let's just make a table to see what we have.
Okay,
So
I'll
one
start
second.
drawing it.
Okay, so we're trying to find UX, right?
Mm-hmm.
So, and then I know that SX, which is displacement, right, is 12 meters, right?
Yes.
I know that AX is going to be 0 meters per second squared. And then I don't know what VX is, but that's insignificant to this question. And I know that I also don't know T. So then on the Y side, UY equals 0 meters per second because when something is launched horizontally, that's how it works, right?
Yeah.
And then SY equals 4 meters, right?
Mm-hmm.
AY, in this coordinate system, I'm going to do negative 10 meters per second squared. You can choose either one. We don't know VY and we don't know T. So in order to find UX, something that I can do is that I can find, using the variables that I have on the Y side, I can actually find what time is, right?
Right.
So 4 equals 0 plus 1/2 negative 10t, right?
So so you did like y equals UIT plus half AYT squared. Yeah.
Yeah, so also this since it falls 4 meters and I have to make it the same coordinate system, it would be -4, right? Sorry about that. So then you would get that t squared equals 0.8. So then ultimately you get that t is about roughly 0.89, right?
Mm-hmm.
So using that information, I'm gonna put it back here.
You can
and
plug
then,
it into.
yes, and then plug it in. Yeah, exactly. And plug it into that equation, and you should get. Sorry, I'll clear this out. Yep. Go ahead.
So it'll be like 12 equals UX, and then it was 0.89, right?
Yeah.
And then
You could divide both sides by 0.89.
Yeah. And then
And you
that
would
would
get
give us
13.4, I believe.
right. Whoops.
Okay, great.
Meters per second, right?
Yeah.
So I'll just go to the next one. Yeah, and there's this one which says The segment C when the cannonball of the Ringling Bros and Barnum Bailey Circus is fired out of a cannon with a speed of 24 meters per second and angle of 40 degrees to the horizontal. If he landed in a net 56.6 meters away at the same height from which he was fired, how long was the keys in the air? Okay, so the initial speed was 24 meters per second. Angle was 40 degrees. And then he ended up landing. Okay, so
Actually, for this one, since they gave you the angle, it would be 24 cosine 40 and then 24 sine 40. So
yes.
do you want me to, okay, draw the image on the right and then you can distinct between UX and UI over here.
Okay. So I would draw someone. So you fire out a cannon. So like it was 56. 40 degrees. I didn't accurate drawing.
No, that works. It's fine.
Just fired.
It's asking you how long, right?
Yeah. Yeah, basically what you wrote.
Sorry about that. Yeah, that's AY, right? So I'm gonna keep it as negative 10 meters per second squared. Okay, so then using this information, just simply solve for it, right? Using the X components. This one is super simple, right? Because you can just use this side. You don't really have to do anything with the other side.
Yeah, I thought we would also like use the formula y equals ut, like uyt plus half ayt squared, but we don't even know like the y component. Like,
well, in this situation, time is going to be same on X and Y components. So you can use it on both sides, right? So you can do X equals ut plus 1/2 gt squared, right? And so since you're a reminder that since your acceleration is 0, this gets rid of it, right? So it's just x equals uxt. So in this situation, you get 56.6 equals 24 cosine of 40 degrees is about 18.4. I'll say 18.39. And then what are you trying to find? You're trying to find t, right? So ultimately, you would get that t is roughly 3.08 seconds.
Okay.
You understand the process? Yeah. Does that make sense? Okay. Yeah.
Yeah. So I was just looking at when you wrote uy.
Yeah.
So like ux is the horizontal component, and that would be 0 because it's launched vertically.
Yeah. So think about it. When you're throwing like, so it says a cannonball, right? There's going to be velocity in the horizontal, initial velocity in the horizontal and the vertical components, which is why when we're given the vector, which in this case would be 24 here, right?
Yes.
So in order to find the horizontal component, it would be 24 cosine of 40 degrees and 24 sine of 40 degrees. Does that make sense?
Yeah.
And if you're ever confused and you see the degree sign, just know that you should use degrees. Okay. Shriya, do you want to quickly do number 7 and 8, more of the theoretical questions?
Okay. So the question for number 7 asks that if we're going to neglect air resistance and projectiles launched at an angle into the air, what is its vertical acceleration? So if there's no air resistance, the vertical acceleration is just basically gravity. And we know gravity always acts downwards. So the vertical acceleration is negative 10, and then our units is meters per second. And then if you don't have horizontal acceleration, meters per second squared. Yes, it's acceleration. So if you don't have air resistance and trying to find horizontal acceleration, it's essentially 0 because your projectile is not going to be moving. There's no force that's acting on it horizontally. So this would be 0 meters per.
Mhm.
And then at what point does the projectile have minimum speed? Well, a projectile kind of looks like this, right? So it's at the top that would have the minimum speed because it's at the top where the vertical component of velocity is 0. So say at
Vy is
the
0, right? Or Uy is 0?
yes.
No, Vy is 0, sorry.
So it would be at
Yeah.
the maximum height, right? So at the top, basically.
Yes.
Why is it important that such a satellite be above Earth's atmosphere? Well, it needs to escape gravity,
Mhm.
so that's why it's
Yeah.
above Earth's atmosphere.
Yes, that's true.
And what force acts on a satellite that is above Earth's atmosphere? It needs to, so to be clear, it needs to escape, I think, I'm not sure if this is 100% right, but the pull of the gravity of the Earth, right? Because there's gravity everywhere, but yeah. For 9,
Okay.
I'm not really sure. Does anyone else know?
Yeah, so it'd still be gravity
It'll
because
still be gravity, yeah.
because remember we've even learned, like, you know, when like meteors and stuff, like they strike the Earth's atmosphere, it's because of gravity and stuff like that, right? I think, right?
Yes.
Okay, I'll do number 10, and then Meenakshi, you can do number 11, and then I think that will be good, right?
Yeah.
Okay, so I'll go ahead and draw out number 10. Could you zoom out just a little bit? Yeah, thank you. Okay, so I'm gonna draw a picture first because that usually helps me. So this is the one about Jennifer's wedding, right?
Mhm.
So Jennifer is here, right? And she's throwing her bridal bouquet back. So she's gonna throw it back. So obviously we see this projectile motion sort of component, right? And
Yes, that's true.
so this is, I think it told us as well that it was caught at the same height, right? So I'm assuming that that's the same height. 0.60 seconds later, who catches the bridal bouquet? And based on that, that means we'd have to find the different distances, right? Because that's the information that's given. So I'm gonna lay out my given components. So since she threw it with 3.9 meters per second at an angle of 50 degrees to the horizontal, I'm going to assume that here, Jennifer is about 50 degrees. Also, this is not drawn to scale. I know it kind of looks like a 90-degree angle, but it's not. So I'm going to lay out my components, and I would get that Uy equals 3.9, right? Sine 50 degrees. Does that make sense? Because that would be the vertical component, and then you get that Ux is 3.9 times cosine of 50 degrees, right?
Mhm.
And then you know that SY is 0 meters, right? Which is the displacement. And you know that because in your vertical direction, there's absolutely no change in height, right? This is the same point vertically as this, right? Does that make sense?
But you said again the same point vertically. Yeah,
So the reason that SY is 0 is because it's in the same point vertically. So think of it like even in the coordinate system, right? 0, 4, and 0, 8. There's a horizontal shift, but there's not a vertical shift, right?
Mhm.
And then I know that AY is going to be negative 10 meters per second squared, or 10 meters per second squared down. I don't know what T is, and I don't know what VY is. And then on the X side, I know that AX equals 0 meters per second. I don't know what SX, I don't know what SX is. I don't know the displacement, right? And then it says that T is 0.60 seconds, right? Oh, wait, so then this would also be 0.60 seconds, right?
Mhm.
And then what am I trying to find? I'm trying to find SX, right?
Yes, trying to find SX.
So I think this would simply just be S equals, so 3.9 times cosine of 50 is roughly, I believe, 2.51, or you could say 2.5 if you want. So it would be 2.51, that times 0.6. And that's all you're going to use since your formula is going to be UX times T, right?
Right.
And so then ultimately you would get approximately 1.5 meters. So XX equals 1.5 meters. So let's figure out which friend that is. That would be Kendra. Kendra is 1.5 meters away. And so the second part of the question says, who might have caught it if she threw it more slowly? So at first, this question was a little confusing to me. And the only way I figured it out at first was that, so we can see that Mary, Kirsten, and Lauren, there's more distance, right? For them to throw it. Whereas with Kelly, she's the only one with less distance. So I felt like, okay, since Kelly's an anomaly in this situation, I would just go with Kelly. But even if you calculate it, you would also find that Kelly is the answer if you threw it more slowly. And so you could consider that maybe in a situation where maybe the U component would be equal to 3 or 2.9, see which one it's closest to. And obviously you're going to have a decrease in SX.
Mostly Kelly's in front of Kendra, so basically
Yeah,
it would
exactly.
reach her if it was slower. Yeah. Okay. So I think the 11th one, so it says Mubarak jumps and shoots a field goal from the front end of the court into the basket at the other end. A distance of 27.6 meters. Ball is given an initial velocity of 17 meters per second and equal 40 degrees to the horizontal from a height of 2 meters over the ground. What is the velocity as it hits the basket? 3 meters on the ground. So if I draw it, so this is Mubarak, and he throws it at the basket. So let's say that's a basket. It's a distance of 27.6 meters. Ball is given an initial velocity, so UX would basically be 17.1 cos 40. UY would be 17.1 sine 40. From a height of 2 meters above the ground. So this is 2 meters above, and that means it's thrown like from where Mubarak threw the ball, it's like 1 meter, if that's right. And yeah, because the total is 3 meters off the ground. So I think that we need to find for just the overall velocity, or like V, right?
Yeah, so I think it's, yeah, you're right. Yeah.
So I think, so we could use a formula of V equals U plus AT. So, okay, so Vx, we want to find, so that means we have to start off with Ux, so that would be 17.1 cos 40 minus 10.
So
and
AX is always 0, remember?
Oh, right, because we're doing horizontal.
Yeah.
So, oh, okay. Oh, and because is this like a horizontal, like, is this shot like horizontally? So that means that UX is always equal to VX?
I think so. I'm not sure.
Oh yeah, it's because it's thrown horizontally, so like the initial velocity, I mean, that velocity is going to stay constant the whole time.
Yeah.
And then want to find Vy? Okay, so we need to find Vy, so that would be Uy plus Ayt. So Uy is 17.1 sine 40 minus 10t. To find t, well, we have the y value, which is 1. So it'll be y equals uyt plus half ayt squared. So 17.1 sine 40t minus 5t squared equals 1. Is that right?
Yeah, I think so. Pretty sure.
I'm gonna bring that up. Okay.
So 17 times sine 40 is about 11, I think. So you can
11?
yeah,
Is it exactly 11?
it's about 10.991. So you could go with 11.
Oh, okay. So 11t minus 5t squared. So equals 1. Yeah, so it'll be like negative 10 equals negative 5t. So t would be like negative 2, comma 1. Like, so I guess we go with 1 because it's positive.
Well, wouldn't it be negative 5t over 10? Negative 10 is also t equals 2, right?
Oh, okay.
So I would go with 2, I guess, right?
So you can take 2 and then, yeah, so we could just substitute 2. So then you could do, if you plug it in the calculator, what would be 17.1 sine 40 minus 20?
So it'd be basically be 11 squared minus 20, right?
Yes.
Minus 20. To get a more exact number, you should put 2.1006 because I think that might be important. So I wouldn't round off to 2.
Okay, yeah. I did 11 squared minus 20. Or yeah, you can do what Shriya did. Do what Shriya did.
So it's 11 minus 2. It's 11 minus 21.06 because you multiplied it to 10 times 2.106, and that gives you negative 10.06 meters per second as your Vy, and you already know what Vx is. So Vx is Vx, and
Well, which one are you
17.1.
talking about? Are you talking about Vy?
Yeah.
Oh, so what did you do instead? Do you want to say that again?
Okay, what is T?
2.
It's 2.106.
Okay.
So it's 2.106, and then what's 17.1 times sine 40?
10.99.
So make it 11.
Oh, Mimi, so I guess if you did 10.99 instead of 11, you would get 2.106.
Oh, as t?
Yeah.
So you
Okay.
can do that.
So write
Subtract the
t
2.
as 2.106, like Shriya is saying.
Oh, okay. So then that means Vy would be 7.1 sine 40 minus 10 is a 2.106.
Right. So
So
that'd
then-
be about 10.99.
Oh, wait,
It'd be
so like if
negative.
you
10.99 minus 21.06.
Yeah. I mean, since it's so close, you can literally make. You can do 11 minus 21.06.
Yeah, do 11 minus 21.06.
wait, I don't have a calculator with me.
Okay, yeah,
It's negative 10.06 meters per second.
Negative 10 point what?
06.
Okay.
So that's your Vy, and then what's your Vx?
Okay, so that was 17 cos 40.
Which is
about 13.01,
13.1.
13.1.
Yeah, so just to
13.
find the velocity, we could do like v equals vx plus vy. So
Squared.
Squared.
the square root, right?
No,
It's
but
basically the Pythagorean theorem.
Right. So that'll be like 13.01 squared plus.
it's 13.1 squared. Just just delete the 0. Yeah.
Okay.
Yeah.
So then what would that be if we squared?
That would give you
That would give you 16.4 or no?
Yeah.
Oh, okay. Yeah, so I'll give 16.4
Mm-hmm.
is the B.
Yep. So this is a very multifaceted, challenging problem, but it's so, yeah.
Yeah.
Okay, yeah. I think that's it. We did a bunch of problems. That's a good practice.
Yes. So thank you everyone for
Thank
watching.
you for joining. Yeah. Mm-hmm.
And good luck on your quizzes.